harvest is well underway in the U.S. I work with a lot of different brands of dryers: GSI, Sukup, Brock, MC, Nico, some grain handler, and then some various odd stuff, GT, and a couple things. So I work on drying in the U.S. from California, dry pistachios, uh, Oklahoma, we dry corn. The rest of the states, the rest of the areas here are all corn. So the first states we dry in Oklahoma, Kansas, Kentucky, Tennessee, Missouri, Illinois, Indiana. Harvest starts up across here in September. Early in September, harvest starts, and it works its way up across. And I do tech support in everywhere where the map shows red. So we work our way up through, and we start off in harvest where in the warm areas, not as wet a grain, and it really intrigues me how every year the more I do work out here in this area with grain dryers, the last 3 years, every year it's been that I start changing some of my ideas on grain drying as far as what works, what don't work, because it's like, well, there's a lot of things that work out here. Like, it is so easy to make a dryer work right in this area. You take Indiana, Illinois, Iowa, it is Nebraska, Kansas, Oklahoma, Missouri. It is so easy to make a dryer work right. Actually, I missed a few states here. I deal with Virginia, Delaware, and New Jersey also. So I missed a few states down in here. And this is all easy. When I am working with grain dryers, the majority, a big percentage of the work I do on grain dryers is across the north. So why do I do way more work on grain dryers in New York than I do Iowa? Even now, very little in Iowa compared to New York and up here into Maine. Now, Maine, they don't have much. New Hampshire and Vermont, not a whole lot. But for New York, Pennsylvania, even in Connecticut, like Quebec, Ontario, a lot of grain dryer support. And the thing I find interesting is up here in the Northeast, like you take this area here, and the grain drying, if you can get a grain dryer to work up in here, you can make it work anywhere. Grain dryer companies test their dryers out here in this area. Well, if you're out here, any dryer can work because your humidity's low, you're removing 5, maybe 10 points of moisture. Up here in the Northeast, about the time like I start to think like halfway through harvest, we're getting up here into the northern states drying, I start getting some ideas how dryers work and how things may not be quite like I thought they were. But till this time of harvest, I start seeing this northeast drying, like up in here, Quebec, Ontario, Maine, Vermont, New Hampshire, New York. If you can make a grain dryer work up here, you can make it work anywhere. Because when you're bringing 28 to 32% moisture out of the field, 27 to 33% moisture out of the field, if you can make that dryer run in auto, drying that kind of moisture, it'll work in anything. So I really think, and this is a message to the grain dryer manufacturers and the people who know people. There's no reason that we are still running grain dryers where we're calibrating moisture sensors. Like, if you went and bought a moisture sensor, a Dickie John or a Perton moisture sensor, and they said, oh, you need to recalibrate it every 5 days. you would say that is junk. I'm not paying for something that I'm going to need to recalibrate every 5 days. And I'm going to say any moisture sensor that you need to recalibrate more than twice a year is no good. It's useless. So grain dryer companies try to run grain dryers in auto. They have an incoming moisture sensor. They have, maybe this is all one plenum and it's a tower dryer that blows straight up, but it's going to be hotter up here at the top than at the bottom, or it's a multi-plenum dryer or a one plenum dryer. Then maybe you have full heat, or maybe you have a cool section. And then at the bottom, we place a discharge moisture sensor. And we say, we're going to watch the incoming moisture and the outgoing moisture, and we're going to adjust the unload speed, and we're going to automate the drying process. Well, this sounds great on paper. And the best way to do it, like if your dryer automation makes its decisions off of this discharge moisture sensor, you're making decisions 45 minutes after it's too late. Like till it comes through this cooling section, or if this is drying, till it gets out of there, it should be making its decision when the corn is up here on how fast to run that discharge speed, not when the grain is already dry. Because once it goes out of the dryer, you're not changing it then. You can't change the moisture after it leaves the dryer. Maybe a little bit from air in a bin, but not enough to make a difference. We want it coming out the dryer the right moisture. We're at the place in our country where we have cars that drive themselves. You punch in your address you want to go, and it drives there. We have AI that can write software code. We have technology at our fingertips that man didn't have back when they went to the moon. So why are we making decisions in our grain dryers like we are? Now, there are brands of grain dryers. I've worked on a lot of brands of grain dryers, more than what get made in North America. And there are brands of dryers, some local, but that they watch the incoming moisture. And they say, okay, so if this is a screen type dryer and it holds X amount of bushels, it takes X amount of time, let's say a screen type dryer with 80 CFM's airflow per bushel, and we're running 180 plenum temp, it's going to remove about 7 minutes to remove 1 point of moisture. If it's a mixed flow dryer with 40 CFM's of airflow and 180 degree plenum temp, it's going to take about 12 minutes to remove a point of moisture. So some automation companies have come to the place where they throw a moisture sensor up at the intake, whether that's at the bottom of the wet bin or on the top of the dryer. The ones that go on the top of the dryer, that's a really bad idea. I like them on the discharge of the wet bin where they're in a better location. And we watch the incoming moisture and we calculate and we say, okay, at this plenum temp, it takes this amount of minutes to remove a point of moisture. The corn's coming in at, say, 25%. We want it coming out at 15, so it needs to take 70 minutes to go down through. So we break up our dryer into zones, imaginary zones, and we watch what moisture is in each zone. Like, okay, we're unloading at so many bushel an hour. The dryer unloads at, let's say we're unloading at 1,000 bushel an hour. The dryer holds 4,000 bushel. So in an hour, our grain, that 25% corn is going to be here. Now we have 20% corn coming in that's here. So now we know this grain here needs to stay in the dryer for, let's say, 70 minutes to remove that point of moisture. So we adjust this unload speed all based off of incoming moisture, which this is actually the most intelligent way I've seen a grain dryer run. And then what you do is the discharge moisture calibrates the minutes to dry. So based off of what the discharge moisture is doing, That calibrates our algorithm for how long the grain needs to stay in the dryer. So the incoming makes the decisions, the discharge calibrates. That is the best way to run a moisture control system. Another way to run a dryer in automation is having temp sensors down through here. One way that people have run them is one single temp sensor watching one location on the dryer. Well, if you start to slow down here because this grain is wet, but this grain is drier, then soon you have this big temperature swing where we're slowing down, and when this grain gets down here, now it's way too hot, now we're speeding up again. And we do lots of chasing our tail trying to make the grain dryer work in auto. When in reality, single point on temperature, very bad idea, terrible idea. Now, if we put a sensor in here, 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 and here, and we average that temperature, if we run off that average, if our temperature starts to drop on our average, it starts to slow down. Say we have wetter corn coming in here, and due to evaporation, it's keeping the corn from heating up because it's wetter. So this temperature is cooler. Now it'll start to slow the unload down. But this starts to get hotter, so it speeds it up. So this slows down, and as it comes down through, it keeps slowing down and slowing down more and slowing down more. Maybe we get dryer coming in and it starts speeding up again, but this down here keeps it from going too fast because this here's not warm enough. So with the 4-point sensing, we can make a dryer run on temperature. So then it runs on temperature, but depending on your test weight of corn, incoming moisture, there's a few variables, that temperature setting on what you need to set that dryer can vary. That can vary where every couple days you're making a slight adjustment to your temperature setting. Now that there, with doing it that way, and also depending how them sensors are installed, depending on the design of this dryer and how them sensors are installed for how good of an average of the corn in that section you're getting. That makes a big difference also. So if you're not sensing in the middle of that corn, that's going to affect what your temperature setting needs to be also. Now what you can do is, so you're running on temperature, you can say, okay, I'm going to set a moisture where my dryer is set the moisture. The moisture watches the unload, makes decisions based off these temperature sensors. That temperature set point is based off of what the outgoing moisture is. It's called cascade controls. You can look it up on YouTube on how it works. In industrial automation, it's something that's been done for many, many years. So you set your discharge moisture, and then your discharge moisture decides what the average temperature set point should be. And then you never have to worry about what that temperature set point is. The discharge moisture makes the adjustments, and it keeps, if your test weight changes, it doesn't matter. So why can't we make, with all these different ways of running a dryer, and there's more ways also and different variances of the ways which I've explained. There's so many different ways of running this dryer with so many different sensor configurations. But we have a problem. We can't make a dryer work when we're running 28% to 33% corn. We can't make a dryer work when our incoming is varying from 25% to 31%. Why can't we make a dryer work then? Because it doesn't matter how good of a computer you have, how good of a computer program you have. It does not matter as long as this outgoing sensor is some $1,000 sensor that you need to calibrate. Because You give bad information to a computer. I don't care who wrote the software. You give bad information to a computer and it's going to put bad information out. I want to say one thing, if you're using a PID loop to make decisions on your unload speed, it's not going to work unless you have an auto tune. It needs to tune itself as it goes. So if it's making decisions off this incoming sensor, if we are using a PID loop for making decisions, there better be a tuning that it automatically tunes itself. There's companies that do this already in their dryers. There's very common in industrial automation. But all of that software stuff aside, if you are having to calibrate this discharge moisture sensor, let's say you're calibrating this discharge moisture sensor once a day. That is, with the technology we have today, that is 100% unacceptable. Not acceptable at all. If you can't run through a season without calibrating your discharge moisture sensor is useless. And anybody selling that should be ashamed to sell a sensor that they call a discharge moisture sensor that needs to be calibrated by the user. Now, sorry, I get a little sarcastic. It's getting towards the end of harvest. But this should not be calibrated. This should be something that is as accurate as a certified moisture sensor tester. We go out and we spend $400,000 on a grain dryer. And we run that entire grain dryer on a $1,000 discharge moisture sensor that we got to calibrate every day. Think about it. It is, with the technology we have today, this is terrible. You might say, well, your moisture sensor works good. Really? Let me put that moisture sensor in a dryer, vary the incoming test weight by 4 pounds, vary the incoming moisture by 6 pounds, drying corn in the Northeast, and I'll show you a moisture sensor that you can't keep accurate for 10 hours straight. Does not matter what sensor you have. I have yet to see them work when you have a big variance in test weight and moisture. When I get my Dickie John, when I get my Pertin tester that's certified, I put that corn in there and it is accurate every single time. And you're going to say, oh, it can be 0.25% off with your certified tester. Yes, it's within 0.25% each way. So within 0.5% every single time I test, no matter what. So I have an idea for grain dryer companies. So if you make grain dryer controls, this is for you. This is something that I wish somebody would build. I would like if somebody would build a dryer. Now, I talk to a lot of people, and I come up with these ideas, and there's people who give me ideas as I talk to them. So these are not 100% my ideas. Some of these are from other people. So let's say, okay, let's just put it like this. So your grain dryer, whether you are running it on this incoming moisture where you're making decisions off this incoming moisture and minutes to remove the moisture and watching that grain down through, keeping track of that grain as it moves down through, or whether you are running multiple temp sensors and making adjustments off this discharge moisture. If we are going to build a grain dryer controller, an automated grain dryer controller, that is worth selling. We need to have a discharge moisture sensor that is as accurate as a certified tester every day, all day. You might say that's not possible because of vibrations on the dryer, because of 1,000 different things. And I understand what you're talking about. And I'm going to explain here that coming out of the dryer, this is just an idea, and I wish somebody would implement this to make this work and tell me if I'm crazy. But out of the unload, your unloaded corn, let's say, goes out here. Let's say your corn coming out of the dryer goes out the orange line. And you have a 2-inch pipe that comes off that unload, goes to a 4-foot by 4-foot by 4-foot steel box, insulated with styrofoam, temperature controlled inside, with a Dickie John or Purton certified moisture tester. And I know some of Purton or Dickie John, they may not even want to work with anybody on this. And maybe that's not the answer. Maybe it's a near infrared sensor in here checking the grain. But this tester in this box needs to test grain density, test weight, however you want to do that. I'm going to say test weight is the best. And the reason I'm going to say that's the best is because that's what the certified testers are doing. That's my only basis for that. Test weight, moisture, temperature, everything in a certified moisture tester capacity where it is accurate. We buy a $400,000 dryer and we throw a $1,000 moisture sensor on it. I say, let's put a $20,000 box over here, or maybe this is a $30,000 box. But with this box, every 30 minutes, a sample is sucked through a 2-inch pipe to this box, discharged into a certified moisture tester. We test weight, temperature, moisture. We give a certified reading. It dumps that sample, blows it to wherever your unload conveyor is going. Every 30 minutes or every 15 minutes, we pull a sample. Let's say every 15 minutes. We pull a sample off the unload. We test it through a certified tester. We discharge it to our elevator or wherever our unload is going. Maybe it's getting discharged back here to the elevator. We have this here tester box setting on a separate block of concrete, and we have this setting on a separate block of concrete, and so that this thing is working properly, not being affected by the vibrations of the dryer or the moisture or anything. Separate. So you might say a Dickie John tester or a Purton tester is going to be junk in short time for taking a sample every 15 minutes. Well, taking a sample every 15 minutes, that is, let me see, 24 hours in a day times 4 is 96 times a day. You're telling me an elevator that gets 96 truckloads in a day and pulls a sample from each wears their tester out a couple times a year? I don't think so. If you could sell an elevator, a grain dryer, that you walked up and hit go, this moisture, and the outgoing moisture was 100% accurate 100% of the time, you could charge $50,000 extra for your grain dryer all day long, and you could sell it. So why don't we have this? Also, these other sensors, if we actually build a dryer where these sensors are monitored individually, making decisions, this sensor here, making decisions, if we have 4 temperature sensors and an incoming moisture sensor and a certified tester out here, if one of these sensors goes bad, we can build a computer program that will tell you if a sensor is reading inaccurate. That it will tell you if a sensor is reading inaccurate. You don't have to say, oh, let's go calibrate the moisture sensor. Let's pull a moisture sample to see if it's putting out the right moisture. No. The computer should be telling you if a sensor is bad. Because if we have an accurate reading here, we can say, wait, because of what this is doing, we know this temp sensor, this grain temp sensor, or this incoming sensor is reading more than 1% off, because here we have a baseline where we know for a fact exactly what's coming out of that grain dryer. So this is a shout out to grain dryer manufacturers that if you have not, like, it's time we start putting controls on grain dryers. We have autonomous cars. We spend 500,000, hundreds of thousands of dollars for grain dryers. And we're calibrating the moisture sensor multiple times a day. I'm going to say, wake up, America. It's time we sit down and build dryer controls. You might say, so, grain dryer repairman, if you're so smart, why don't you build your own grain dryer controls? Well, here's how it works. I like working with dealers. I like working with manufacturers. I don't build a grain dryer. There are companies that build good grain dryers. But it's time we start putting controls on these dryers, because I don't sell dryers. I'm not interested in selling dryers. I don't get paid by manufacturers. I don't make money off selling grain dryers. I make my money doing tech support, doing consulting. And I don't make money consulting with manufacturers at this time. But I'm saying it's time, as the manufacturers, it's time to start building a dryer control that if we're spending hundreds of thousands of dollars on a grain dryer, let's put a moisture control on it, or at least offer it with a moisture control that actually works. It would I'm certain it could be sold. So this is not that complicated. This is stuff that is done in the industrial automation and robotics area already. So why don't we have this technology on our grain dryers, built into our grain dryers? Co-ops could save lots of labor if their systems could if their grain dryers could actually run in auto. Farmers, large farmers, could save lots of money if they could go hit start and it actually ran and it was actually accurate. But if we can't trust this discharge moisture sensor, or if we're making our decisions after the grain's coming out of the dryer, we've failed. And you might say, well, your dryer works. I want to see your dryer dry 25 to 32% corn, varying 4 pounds of test weight, and actually work. I almost get convinced there are controls that work. And then I get into the Northeast harvest. And when I get into the Northeast harvest, where we're working with these big swings, and we put, you name the controls. You name the controls, and they don't work. They do not work. There is no automation that works when you are swinging the test weight and the moisture that extreme. So, grain dryer manufacturers, I just gave you years of research right here. Put a certified tester here. Maybe it's not Dickie John or Purton. Maybe it's a near infrared. That is the future. I've talked to multiple companies who build near infrared sensing. I've worked on alfalfa dryers, alfalfa pellet mills for making alfalfa pellets. They're using near infrared sensing, very accurate moisture sensing, not to the point where I'm calling for, but this turned into a long video. I did not mean to make a rant. I just want to call out grain dryer manufacturers to say, yous are coming to the end of the harvest season, and it is time to start doing research and development. And not research and development that is halfway. Because if you do not start the research and development on this, somebody's going to build it and you will be left behind. The leaders in this are the leaders of the future. Future grain dryers are going to have accurate controls. Future grain dryers, mixed flow dryers are going to be enclosed. If you are not developing them, I recommend you get started. Do you want to be the leader or do you want to be the follower? The leader ends up capturing market share that others wish they had.